Hey there, class. Today we're all about trying to figure out how to solve a system of equations, but this time using my favorite method, and that's the elimination method. Or you could also call this the linear combination method. So make sure you're all set to go. And here we go. Our first system that we'll start out with is going to be the system of 2x plus 5y, and we'll set that equal to 16. Second equation we'll say is 2x plus 3y, and we set this equal to 12. Now, other ways to solve the system that we looked at before was graphing, where we had to figure out some graph paper and find where those two lines intersect. Another way would be with substitution, where we solve one for one variable, but that's not really all that handy here. One of the things is, since they're both in the standard form, I'm going to do what's called linear combination, or the eliminator method, or the elimination method. What I'm going to do is, I notice I've got a 2x and a 2x. Both of these guys are the exact same value, and I'm going to end up subtracting the top from the bottom. So what I do here is I take a 2x and a 2x, what I have circled right there, and they just cancel out. 2 minus 2 is 0x, or it just kind of cancels out to nothing. All right, I'll also take a look over here at the 5y and the 3y. And remember, I'm going to subtract 5y minus 3y. So 5 minus 3, that's going to give me a 2y. All right, I can put a plus sign in between them to let me indicate it's a positive 2y. And it's still going to be equal. So it's still going to be equal. And the last thing I want to do is try to figure out what happens over here to the equal sign. Remember, it's subtraction, the top minus the bottom. 16 minus 12, well, that's going to give me a positive 4. So what I have done right now is I have eliminated one of the variables just by combining the two equations together. And that variable that I have eliminated is the x, because 0x, 0 times anything, is just plain old 0. So what I can do is rewrite this equation to be a 2y equals 4. Then I can divide both sides by the 2, and I can say, well, y equals just plain old 2. Well, that's awesome. That's great, but I'm not finished. What I want to do is figure out the x value. And I could work my work here and try to figure out how to solve for x, but I'm just going to use my substitution method because I've already got one of the variables. And I'm going to pick one of my original equations to work on. And that original equation maybe is this guy down here because it's smaller numbers. All right, and if I substitute that 2 in for y, I'll end up with the equation 2x plus 3 times by, now remember, I'm substituting in my answer here of y, which is a 2, and then I'll say this is still equal to 12. So now I'll say, well, 2x is just plain old 2x. 3 times 2, that's 6, and it's still equal to 12. I solve this two-step equation. I can subtract the 6 to both sides. And I'll say 2x, well, that's equal to 12 minus 6 is 6. I can divide both sides by 2, and I get x equal to 3. So my final answer there, I could say, is x is 3, y is 2. I could always check and verify that it's true for both of these equations. 2 times 3 is 6. 5 times 2 is 10. 6 plus 10 is 16. 2 times 3, well, that's 6 again. 3 times 2 is another 6. 6 plus 6 is 12. Super. It works. It's great. I got it checked off. I've got my answer. X is 3. Y is 2. Let's try one more just to make sure we get the hang of it. And let's get some more space. Maybe I'll use this tool and get some more space up here. There we go. All right. And another system. So another one here. We're going to say this time 5x plus 3y is equal to a negative 2. And the other one is 2x minus 3y. And we're going to say this is equal to a negative 26. This time, if you notice 5x and 2x, I can't just add or subtract them and they're gone. But I do have a 3y and a negative 3y. So remember, I'm trying to eliminate one of the variables. So it might help by adding the two equations together. If I do that, the 3y and the negative 3y, they get eliminated to a 0y. That's great. Remember, the step here is adding. adding to cancel out the y's. So I have to add the 5x and the 2x. 5 plus 2 is 7, so that's 7x. If I want to think about it, it's really plus the 0y, but I don't really need that 0y. And then on the end here, it's still equal to a negative 2 plus a negative 26. Well, that's a negative 28. All right, the 0y kind of all cancels out. So I'm left over now, if I want to rewrite this equation, to be a 7x equals negative 28. And this is a pretty straightforward one-step equation. Divide both sides by 7, and I end up with x is equal to negative 4. We eliminated y to figure out what x is, negative 4. Now I'll use substitution, and I'll pick one of those two equations. Doesn't really matter which one you pick. I'll just pick the first one up top. And what I'll rewrite this as is 5 times by the x value. Well, we know x is right here at negative 4. So 5 times by negative 4. And I'll continue this equation. Plus 3y is equal to negative 2. All right. Well, 5 times negative 4, that's a negative 20. Plus 3y is equal to negative 2. So it's a two-step equation. Let's add the 20 to both sides. If I do that, the 20s drop out, and I have 3y is equal to negative 2 plus 20. Well, that's going to be a positive 18. And then I can divide both sides by the negative 3, or by the positive 3, and y is equal to a positive 6. So my final answer, if I want to write this as an ordered pair, would be a negative 4 for x and a positive 6 for y. And don't forget to check your solution. So negative 4, positive 6, you check them, you substitute in and make sure they're still holding true. And that's how we use the elimination method. Great. See you next time. Bye-bye.